Okay, so now we'll discuss how to move towards a certain object in 3D in this case, but it applies to 2D as well. So I made a script here. Let's create a transform target transform. So we'll move towards this transform. And in this case, we have a rigid body on this guy here in the scene. So in Unity, there are multiple ways of moving objects around. One is you teleport it with transform, translate. The other one is, like in this case, we use the physics item, so the rigid body will be with some velocity, and you can use some, you can use vector 3 lerp to move the position over time. But in this case, we'll use the physics system. So in here, we have to say rigid body. You need a rigid body. And in the start function, let's get that. So rigid body, get components, rigid body. And we'll delete the update. We just want to move this towards the target. So I have two targets here, so we can demonstrate that it works for any position. Target so we need to calculate the difference between the position of our player and the position that we're going towards. So for that, let's create a function here, void move towards function, and in here we use a certain transforms. Let's say transform target transform. So we need to calculate the difference first. So vector 3 equal. Yes, the target transform position minus our position. So transform position like that. Okay, so we calculate the difference between the target position and our position. And in 3D, we want to maintain the y of this object that we're moving. So we say diff y becomes transform position y, so we maintain the y. And then we have to normalize this vector. So we want to make sure that the length of this vector, so you can imagine it as a line in 3D, we want to make sure that this is the length 1. So it's just the direction. So we'll say this normalize like that. You can do that like that, or you can also put round brackets like this and say normalized at the end. So that's the same. You can use the normalize function on, or say normalized here. So after we normalize, we want to move that rigid body towards the target. So we say the velocity will be that difference, which is the direction, multiplied by some move speed, let's say 10 in this case. I don't have a variable for that, just say some value, random value. So let's go here in the interface and place the script on our player. And then let's add the red capsule and the green capsule here. So we'll demonstrate with both. So let's do that with the first one. So we'll call the function here with the first transform. Now there might be an issue here because I don't remember the order in which you have to subtract here. So you might have to add minus to this vector 3, but let's see first. So now we should move towards the green capsule. So you see it works, it goes to that. Now let's try with the red one to make sure that it works with any transform. And I will go through the code again so that it is clear. And if you want, actually I will show you in Paint how that, in 2D, how that works. So that is very clear to you. So you see it works with any transform. So let's go through the code again. We need a difference between our target and our position. So first the target and then our position. That's very important because otherwise it goes the complete opposite way. Now we want to maintain the y from our in this case we want to maintain the y of our player. So we say that that vector y becomes the y of our player, and then we normalize, so this vector 3 becomes of length 1, and then the velocity will be that the direction that we calculated times some speed, so the direction times some speed. But let me show you what normalize means. So when I say we make that vector 3 of size 1, let me show you what that is. So imagine I will show it in 2D because in 3D I don't know how, so we'll assume it's a vector 2 instead. So we have the 2D space like this, and then we have our vector. That's the, let's say that is the difference that we calculated. And actually, I should have used this. Wait, one second. Yes. So let's say that's our vector, and let's say that this is of length 5. Okay. Normalize just makes it length 1, so it will make it like that, length 1. So that's what normalize means. Okay. So that's how you move towards an object. You have to calculate the difference between those two positions. And in this case, we want to maintain the y because we want to move parallel to the platform in this case. But in other cases, you might want to keep the y. So it depends on the situation. So that's how you move an object towards another one.